When the Ukrainian military first received FV103 Spartan armored personnel carriers in July 2022, it wasn't a shot heard around the world. In fact, most military analysts agreed that the vehicles likely wouldn't have much of an impact on the battlefield. After all, even then, they were far from modern infantry fighting vehicles, with Britain itself retiring them more than 15 years ago. Ukraine became the 7th country to use the vehicle, with Latvia being the only other European country to still have them. Compared to Russian modern military equipment, the Spartans look paltry and inadequate. And yet, 3.5 years into the war, the number of Spartans on the battlefield grew from 35 to close to 200. And out of that number, only approximately 35 have been lost, according to the open-source intelligence monitoring company Oryx. The survival rate of about 82.5% is on par with some of the most successful Western and Ukrainian systems, suggesting that these humble vehicles are much more than meets the eye. So, let's examine exactly how Ukraine turned vehicles meant for the UK's junkyards into frontline monsters that could tumble with Russia's advanced tanks. Now, let's begin with the actual specs, what they represent, and why they made the Spartans nearly obsolete in the first place. The FV103 Spartan was developed in the 1970s as part of Britain's Combat Vehicle Reconnaissance Tract, or CVRT family. The design philosophy was simple: create a fast vehicle that could transport specialist teams such as anti-aircraft crews or reconnaissance units across the battlefield while keeping pace with heavier tanks. To achieve this, British engineers went all in on trying to shed as much weight from a traditional infantry carrier as possible. The hull was constructed from welded aluminum alloy instead of steel, maxing out at just 60mm thick on the frontal arc. This provided protection against 14.5mm rounds from around 200 meters and shrapnel, but nothing more. A direct hit from any modern anti-tank weapon would punch straight through. The vehicle's 195 horsepower Jaguar engine could push it to 60 miles per hour on an open road, and only when carrying minimal loads. The flip side is that the weight-to-power ratio meant it could climb a 60-degree incline. The squad compartment held just 4 soldiers, not including the 3 crew members, which could be accessed through a rear door or roof hatches. The vehicle's armament consisted of a single 7.62mm L37A1 machine gun in a commander's cupola. This was enough for self-defense against infantry, but ultimately useless against armored targets, even another Spartan. The combination of lackluster armor and having only niche operational capabilities ultimately meant that the Spartan was never really used in actual combat, instead serving as auxiliary transport for the UK military. Even then, the steady improvements in armaments of traditional infantry fighting vehicles meant that the tank was rapidly approaching the point where it would get shot down by similar auxiliary vehicles. This led to the UK replacing the Spartan with the more capable Panther Command and Liaison vehicles. The last Spartans in British service were withdrawn by 2009. For context, compare the Spartan to Ukraine's existing Soviet-era equipment and Western alternatives. The BTR-3, Ukraine's standard domestically produced APC, weighs 16.4 tons and carries 3 to 6 troops, while being armed with a 30mm autocannon. The American M113, which Ukraine also operates, weighs 14 tons and transports 11 soldiers. The M2 Bradley that Ukraine desperately wanted weighs 27 tons, carries 6 troops plus crew, and mounts a 25mm autocannon plus TOW, or tube-launch, optically tracked, wire-guided anti-tank missiles with sophisticated thermal sights. Against these benchmarks, the Spartan looks pathetic. Yet when the UK pledged to send 35 Spartans in 2022, and then increased that pledge to over 120, Ukraine accepted gratefully. When the Serhiy Prytula Charity Foundation crowdfunded $6.5 million in just 36 hours to purchase 60 additional Spartans from UK private sellers in November 2022, Ukrainian soldiers celebrated. When the Ukrainian World Congress acquired 13 more Through the Unite with Ukraine initiative, frontline units competed for them. The cheering was due to Ukrainian forces seeing something Western analysts missed. In a war dominated by drones, artillery, and constant observation, the Spartans' apparent weaknesses were actually hidden strengths. Ukrainian crews didn't even bother trying to use the Spartan as a frontline infantry fighting vehicle. That would have been suicide. Instead, they transformed it into a high-speed armored taxi, optimized for rapid insertion and extraction missions under the most dangerous conditions. One Ukrainian soldier explained the operational concept as move in unnoticed, complete the task unnoticed, drop off the assault team unnoticed, get in, get our guys out. This was radically different from NATO's doctrine of mechanized warfare when the vehicle was originally designed, where infantry fighting vehicles advance alongside tanks while suppressing enemy positions with autocannons. A typical Spartan mission in Ukrainian service works like this. The vehicle waits, concealed in a tree line or behind terrain, with its engine off to minimize its thermal and electromagnetic signature. Ukrainian FPV drones scout the route ahead, identifying Russian observation posts, artillery positions, and drone operators. When the mission commander determines the window is clear, the Spartan's crew fires up the engine and accelerates rapidly across open terrain. The goal is speed and surprise. At 60 miles an hour, the vehicle can cover roughly a mile a minute, drastically reducing the time window for Russian forces to spot it, transmit targeting data, and launch counterattacks. The compact size that seemed like a weakness became an advantage. The Spartan is one of the narrowest and shortest vehicles in its class, with a length of under 17 feet and a width of 8 feet 2 inches, meaning it can hide in positions that would expose larger vehicles like the BTR-3 or Bradley. Its low silhouette at slightly under 9 feet tall makes it harder for Russian drones to acquire and track, especially when moving fast across complex terrain. When Ukrainian forces needed to evacuate wounded soldiers from exposed positions near Bakhmut, Spartans proved invaluable. Due to the relatively low benchmark capacity, Ukrainians would often need to be crammed into the transport quarters depending on the severity of their injuries. Some evacuation runs became legendary among Ukrainian units, fitting more than a dozen soldiers. One crew member reported that, on the way back, there's no gear inside, so you pack them in like Tetris. This far exceeds the Spartans' design capacity of 7 total personnel. But in emergency evacuations, Ukrainian crews prioritize saving lives over following specifications. The vehicle's lightweight also provides a crucial advantage that Western analysts consistently underestimated: ground pressure. At just 10.6 tons distributed across its track surface area, the Spartan exerts roughly 0.4 kilograms per centimeter square of ground pressure. Compare this to a main battle tank like the T-72 at 46 tons, creating approximately 0.9 kilograms per centimeter square, or the Leopard 2 at over 60 tons, generating even higher pressure. This difference matters enormously in eastern Ukraine's notorious black soil, which turns into thick mud during spring thaw and after heavy rains. Heavier vehicles bog down, becoming vulnerable targets for artillery and drones. The Spartan's low ground pressure allows it to traverse terrain that would immobilize heavier armor, opening tactical options that didn't exist for units equipped with BTR-3s or Bradleys. In fact, some reports would suggest that a soldier jumping off the vehicle could get stuck in the mud where the Spartan previously passed through without an issue. Even more remarkably, the lightweight may provide some protection against anti-tank mines. Most pressure-activated anti-tank mines are designed to trigger at weights of 150 to 300 kilograms, sufficient to ensure they detonate under tracked vehicles but don't waste themselves on lighter threats. The Spartan falls into a grey zone, where some mines might not trigger consistently, especially older Soviet models that Ukraine and Russia have both laid extensively. While this isn't guaranteed protection, it could create survivability margins that simply don't exist for heavier armor. Of course, the Spartan replacements included major armor improvements to make them less vulnerable upon detonating a mine or getting shot from a larger caliber, so it's unclear how effective they were at dodging mines. But Ukraine realized quite early that some technical specifications of vehicles simply ceased to matter in the grand scheme of the war. The invasion quickly turned into a slog where neither side could advance reasonably. This led to the absolute dominance of unmanned systems. Both sides deployed tens of thousands of drones monthly, from simple commercial quadcopters dropping grenades to sophisticated FPV racing drones retrofitted with anti-tank warheads, to long-range loitering munitions like the Russian Lancet and Ukrainian modified systems. Traditional tank doctrine assumed that heavy armor and active protection systems would provide survivability. But drones attack from above, hitting the thinnest armor on any vehicle's roof. They also strike in swarms that overwhelm active protection systems like autocannons or even passive add-ons such as netting. And even swarms of drones can cost orders of magnitude less than the vehicles they destroy. In this environment, the Spartans' lack of heavy armor became paradoxically advantageous. Because it was never designed to survive heavy anti-tank weapons, Ukrainian engineers were free to optimize it entirely for drone defense, without worrying about maintaining a balance between protection types. In a video from late July 2025, you can clearly see Ukrainian Spartans being fitted with a similar anti-drone netting used for main battle tanks and other IFVs. And in much the same way, the metal wire net is then covered with camouflage canvas or similar material to allow for the aforementioned lie-in-wait tactic before the vehicles were needed for transport in the first place. Alternatively, some vehicles were retrofitted to serve as an auxiliary combat equipment rather than transport. This was done by attaching a turret that holds an M2 Browning heavy machine gun and an automatic grenade launcher instead of the stock autocannon. While this precluded the vehicle from receiving the anti-drone measures, it drastically increased its offensive potential. But pure technical specifications alone don't fully explain why Spartans had so much success in Ukraine while they were originally headed for the Junkyard. In actuality, the vehicles were simply outcompeted by newer designs when serving in their native NATO militaries. But Ukraine's practical requirements allow a sort of reset on those favoured old designs. When Britain retired the Spartan fleet in 2009, it replaced them with Panther command and liaison vehicles. These were 6x6 wheeled vehicles based on the Italian Iveco medium multi-role vehicle. The Panther weighs 7 tons, seats 6 personnel, and provides STANAG Level 2 ballistic protection. It's faster on roads, more fuel efficient, easier to maintain, and significantly more comfortable than the tracked Spartan. For NATO operations in Iraq and Afghanistan, this made perfect sense. Coalition forces operated with overwhelming air superiority, sophisticated ISR, intelligence surveillance reconnaissance networks, and logistical chains that could deliver parts anywhere within 48 hours. In that environment, wheeled vehicles with lower operating costs and better road performance were ideal. But Ukraine doesn't fight for air superiority. It operates in a near-peer conflict where both sides have extensive artillery, drone swarms, and electronic warfare capabilities. Roads are heavily surveilled and frequently mined or struck with artillery or drones. At the same time, supply chains are contested and unreliable on both sides due to the overwhelming amount of long-range drone attacks happening daily across the 600-mile front. In this environment, the obsolete Spartan's track mobility, compact size, and simple mechanics made it more valuable than newer, more sophisticated alternatives. The track suspension is more stable when going over uneven terrain, and the vehicle's ability to climb steep hills makes it practically invaluable in the same sort of hilly terrain, speckled with fields and ditches, which dominates the Ukraine-Russia front in Donbass. Ukrainian forces are fighting a war that more closely resembles World War II's Eastern Front than the conflicts NATO prepared for. In this context, quantity, maintainability, and tactical flexibility matter more than individual vehicle capability. The numbers alone are telling, as Ukraine received approximately 200 Spartan variants through various channels. Compare this to the number of other Western systems they received. Approximately 100 Leopard 2 variants, 2A4 through 2A6, from multiple NATO countries. 31 M1 Abrams tanks from the United States, of which Ukraine has lost 27. roughly 300 M113 variants, mostly provided by Lithuania from Soviet-era production, 190 Bradleys M2, M3, provided by the United States, with about 40 lost or damaged. The Spartan fleet is numerically significant enough to equip multiple brigades. Ukrainian forces have formed the 251st Territorial Defense Battalion, the 127th Territorial Defense Brigade, and elements of the 67th Mechanized Brigade around Spartan operations. These units have developed specialized tactics that leverage the vehicle's mobility and transport-oriented capabilities. But here's where the story takes a fascinating turn. If Ukraine can achieve these results with 50-year-old vehicles Britain considered worthless, what could it accomplish with the equipment NATO actually considers modern? Britain's Panther vehicles, which replaced the Spartan, haven't been offered to Ukraine. Neither have the track Warrior infantry fighting vehicles that Britain recently retired, though they've been mentioned in potential future aid packages. The far more capable Ajax reconnaissance vehicles entering British service now aren't even being discussed. Part of the reason for Britain sticking to the equipment from roughly the same era as Ukraine's native vehicles is political risk management. NATO countries want to avoid providing such advanced systems because their loss or capture would compromise classified technology. Another reason is training complexity. Modern vehicles require sophisticated crew training that takes months. Finally, there's maintenance infrastructure, with newer vehicles needing specialized facilities and parts that Ukraine doesn't have and can't have. Of course, there's another possibility where Russia declares that some of the donation transfers can tilt the scale too much in Ukraine's favor and supposedly threaten Russia as a whole. In return, Russia could escalate the war by using tactical weapons, including nuclear ones, against Ukraine to speed the war along, so to speak. This intimidation tactic isn't new, as Putin had previously attempted to block the transfers of long-range missiles, tanks and aircraft, and there's no telling where he might draw the next imaginary red line. But the Spartan success suggests these calculations might be overly cautious. Ukrainian forces have proven remarkably capable of adapting Western equipment, improvising solutions to maintenance challenges, and developing tactics that maximize platform strengths while minimizing weaknesses. Consider what this means for the broader Russia-NATO military balance. Russia has lost over 23,000 pieces of military equipment since the invasion began, according to Oryx's documented visual confirmations. This includes approximately 13,500 armored vehicles destroyed, which were drawn from stocks accumulated over decades. Russia's current production capacity is roughly 250 T-90M tanks and between 70 and 100 BMP-3 infantry fighting vehicles per year, which is far short of replacement needs. The country has been forced to pull progressively older equipment from storage, deploying T-62s from the 1960s, and even reported instances of T-34s from World War II appearing on trains headed towards Ukraine. NATO's combined military-industrial capacity dwarfs Russia's by orders of magnitude. According to Polish military analysts, the United States produced over 8,800 M1 Abrams tanks from 1979 to 1993, with thousands in storage, and roughly 135 new ones produced each year to date. Germany manufactured over 3,000 Leopard 2 tanks. Britain produced nearly 500 Challenger tanks, and France built over 400 Leclerc tanks. And these are modern main battle tanks with composite armor, 120mm smoothbore cannons, advanced fire control systems, and sophisticated active protection systems. If NATO countries decided to transfer even 10% of their non-active duty tank fleets to Ukraine, it would represent over 1,000 modern MBTs entering the conflict. Spartans would practically be useless by comparison. The same calculus applies to infantry fighting vehicles, artillery systems, air defense platforms, and combat aircraft. NATO has the equipment. The question has always been political will. The Spartans' performance demonstrates that even junk Western equipment, when properly employed, outperforms Russian contemporary systems. Ukrainian soldiers and engineers aren't really inherently superior to Russia's, which is arguably one of the most experienced military suppliers in the Eastern Hemisphere. But Western military development over the past 50 years even on vehicles considered obsolete, produce capabilities that Russia's current military-industrial complex can't match. Beyond tactical employment and strategic implications, the Spartan's success rests on specific engineering choices that Ukrainian modifications enhanced. Specifically, the M2 Browning provides dramatically improved firepower against infantry, light vehicles, and fortified positions. With a maximum effective range of slightly over a mile, it allows Spartan crews to engage targets that would have been untouchable with the original 7.62mm weapon. The Mk-19 grenade launcher extends this capability even further to 1.37 miles, delivering high-explosive fragmentation rounds that can suppress enemy positions or punch through less armored vehicles. However, these weapons come with a significant drawback. Unlike the original L-37A1, which could be fired from inside the vehicle, the M2 and Mk-19 required the gunner to expose themselves above the turret. Ukrainian crews addressed this by adding improvised armor shields around the weapon mount, such as welded steel plates that protect against small arms fire and shrapnel while allowing the gunner to operate the weapon. The vehicles also received modern communication systems. Some Spartans now carry Harris radios, allowing integration with Ukrainian command networks and coordination with drone operators. This addresses one of the original vehicle's major limitations, where the 1970s-era radio systems are simply incompatible with modern encrypted communications. Fire control upgrades proved equally valuable. While the Spartan wasn't designed as a tank destroyer, Ukrainian forces recognized its potential as a fire support platform. Some vehicles received laser rangefinders and improved optical sights, dramatically improving accuracy at extended ranges. One crew member noted, "The road wheels are rubberized, and that's one of its perks. It's quiet, no metal clanging, and the tracks have rubber pads too, which helps reduce noise." This quiet operation, combined with thermal signature reduction through engine management, makes the Spartan surprisingly stealthy despite lacking sophisticated anti-surveillance systems. In an environment dominated by thermal optics and acoustic sensors, operating quietly provides crucial advantages during insertion and extraction missions. Perhaps most importantly, the Spartan is mechanically simple, which means Ukrainian crews can perform most maintenance in field conditions. When a track breaks, they replace it. When the engine overheats, they swap coolant lines. The vehicle requires neither specialized diagnostic computers nor hard-to-source electronic components. Compare this to the Bradley, which features a complex turbocharged diesel engine, automatic transmission, digital fire control system, and integrated battlefield management computers. When a Bradley breaks down in Ukraine, it often requires transport to specialized maintenance facilities with trained technicians and proprietary diagnostic equipment. This maintenance advantage compounds over time. After months of operations, the Bradley fleet's operational readiness rate drops as vehicles accumulate minor faults that can't be fixed in the field. The Spartan fleet maintains higher availability because crews can address problems immediately rather than waiting for specialized support. The success of Ukraine's Spartan program also reveals how military procurement economics have shifted over time between regions. More specifically, Western militaries have previously pursued increasingly sophisticated platforms, assuming that technological superiority would provide decisive advantages in any conflict. This led to systems like the F-35 fighter jet at $100 million per aircraft, the Zumwalt-class destroyer at $7.5 billion per ship, and the Future Combat Systems program, which got cancelled after spending $18 billion without fielding a single operational vehicle. The logic seems sound. Advanced technology multiplies combat effectiveness, so investing in the best systems produces optimal military capability. But Ukraine's experience hints at this logic breaking down in high-intensity conventional warfare. The problem isn't that advanced systems lack capability, as the Bradley is undeniably more capable than the Spartan in almost every measurable way. Advanced systems simply can't be produced, maintained, or fielded in sufficient quantities to matter when attrition rates are high. Take, for example, some simple mathematics. If a Bradley costs $4.35 million, the approximate unit cost for recent US Army orders, and a refurbished Spartan costs approximately $50,000, which is the price Ukrainian charitable foundations paid UK private sellers, you can field 87 Spartans for the cost of one Bradley. Now, assume both vehicles have similar survival rates in Ukrainian conditions, which appears roughly true based on available lost data. Even if the Bradley is 3 times as effective per vehicle, and even that is debatable in the drone-saturated environment, the Spartan fleet provides 22 times more operational vehicles for the same investment. This naturally allows the cheaper vehicle to be more versatile and usable in actual combat situations. Ukrainian commanders can deploy Spartans on risky missions that would be unacceptable risks for limited Bradley stocks. They can position Spartans in forward areas where rapid reinforcement matters more than individual vehicle capability. This suggests Western militaries have over-indexed on per-platform capability at the expense of fleet survivability, maintainability, and quantity. In counter-insurgency operations against technologically inferior opponents, this didn't matter, as having the absolute best vehicle was worth the financial costs when you can mow down the opposition while sustaining minimal equipment or human losses. But against near-peer adversaries with sophisticated weapons, mass, and availability, might matter more than marginal capability improvement. The Spartan story, much like many others, further drives the narrative that the war in Ukraine isn't a conflict between cutting-edge military technologies where marginal advantages decide battles. It's an attritional struggle where sustainability, adaptability, and will determine outcomes. In that environment, an aluminum box on tracks from 1978 becomes a frontline monster, not through sophisticated electronics or advanced weapons, but through smart employment, rapid adaptation, and the resourcefulness of soldiers who refuse to let those boxes fade into memory. As one Ukrainian crew member put it, the thing was made in another era for another war, but somehow it fits this war too, because when the mission is survival, reliability matters more than shiny upgrades. Thanks for watching. Now, to understand how Ukraine continues innovating with limited resources, check out our analysis of Ukraine's growth to the status of regional military power in this video. Check out our analysis of Ukraine's growth to the status of regional military power in this video. And to stay up to date with vital events in global geopolitics, subscribe to The Military Show for daily videos.